Hello, welcome to this video. In this video, we will see how to build a RAG retrieval augmented generation based chatbot application that runs locally using DeepSeek 1.5 billion parameter digital model. This is how it would look like. The user interface is built using Streamlit. DeepSeek model is sourced using Ollama. I have covered how to download DeepSeek digital model using Ollama in my other video. You can find link to it in description section. In the sidebar, we have options to upload PDF files. More than one files can be uploaded. Once uploaded, you can create a knowledge base, or in other terms, add this custom data to vector database. I have named the chatbot as EduMate just for fun, as I will be using 10th grade science chapter PDF for this use case. Let me load a textbook and hit create knowledge base button. This may take some time depending on the size of the file. Let's give it a moment. Okay, so knowledge base is created and we can go ahead and chat. Let's take a question from textbook. Okay, it's a bit slower as compared to API experience. Moreover, I am running on CPU with 8 GB RAM. Nevertheless, you have full control of it as it is running in local. Okay, so we got the response started with reasoning, chain of thoughts, and finally the answer. Seems like it did a decent job. Before we get to the code, let's have a quick glance of architectural flow. As we can see, user will get to the web app, PDFs are loaded, they are split, and then embeddings are created. Embeddings are nothing but numerical representations. Here we are using Ollama embedding and the model name is Nomic Embed Text. You can actually use other embedding models as well, maybe from Hugging Face or some other models. Feel free to experiment. Once the knowledge base is created, it will be available for query or slash retrieval. Now the important point here is we are actually using the best of both worlds, meaning the best of LLM capabilities augmented with our own custom data indexed within vector database. When the user enters prompt, it is again converted into embeddings, which hits the knowledge base. A similarity search is then done. In this case, we use MMR, that stands for maximum marginal relevance, which works great balancing context, relevance, diversity when selecting the chunks, especially for our use case. The top three closest matching relevant chunks are retrieved, which are then used by LLM model, in this case DeepSeek R1 1.5 billion parameter model, to get output back to the user. All this is facilitated with the help of chain and retrieval functions. In between, we also use custom prompts that guides LLM with respect to its role, behavior, formatting, and whatnot. Now let's head to VS Code. We start by creating virtual environment and installing required packages. You can install them separately or via requirements.txt. I have already installed these into my virtual environment, so let me go ahead and activate my virtual environment. Here we have got two code files. The first one is utils.py that has got all the helper functions, and then I've got chatbot.py having the actual UI where I've got all the Streamlit coding. In utils, we start with importing the required libraries. We have this process document function which loads the PDF content from PDF files using PDF Plumber. We are using recursive character text splitter to split the data into chunks of given size. Embedding is done using one of the Ollama embeddings. We have already seen this in the architecture. Finally, vector store will be created in ChromaDB with these embeddings. Then we have a function getRetriever, which will be used to fetch relevant chunks from the stored embeddings based on the user queries. Here we will use the same Ollama embedding to embed the user query. It will then be matched for similarity using MMR, and 3 matches would be returned. Okay. In chatbot.py, again we start with bunch of imports. Here we have defined custom prompt from the for the chatbot relevant to this use case, its behavior and how shall it respond, formatting, and so on. Then we initialize the chain by giving LLM model specifics, retrieval details. Then we have the session states. This is the function to create sidebar. Started with instructions for user. We got a file upload widget. Multiple is equal to true, indicating we can upload multiple PDF files. A button to trigger creation of knowledge base once the files are uploaded. And once this button is clicked, it triggers the loading of PDF, splits, embeddings, and finally storing data into ChromaDB. Then we have function for chat interface. We provided a title, user input is assigned to prompt with the role of user. We got a chain is invoked and user prompt is passed to it to get the retrievals. Outcome from the retrieval is assigned to response and result is displayed along with role as assistant. And that is it. Note that before you run the code, be sure that Ollama is running on a separate terminal window as well as the required models from Ollama are pulled. Else, model will not be accessible and may result into errors. Now let's run the app. Okay. I hope this video was helpful. Thanks for watching.